Okay. So the second thing, after you define, remember, functions come in groups. And there is star function, and there is a very closely related function, which people forget. The arrow operator. Do you know how to write it? No. What is it going to return? Pointer. It's going to return a pointer. Pointer. Okay. Since I do not remember how to write it, could you go and take the code which I wrote? It's cheating, but what? I always forget the syntax. Okay. Okay. All right. Tell us. Well, this is naive way of writing it. How should it be written, really? Try something better. Okay, let me explain. Let's write it so that when they use cut and paste to copy it, they'll not have to know anything about nodes and pools. We already have this. So, yeah, somebody. No, you don't. No, yes, you do. Thank you. Yes, you do. This is a pointer, this is a star, and this is the address. Yes, thank you. This is what I did not remember. Okay? But again, it's always observe that if you define this, this is, as it were, could be automatically generated. Sadly enough, it isn't. We shall see that there is a typical thing. We're going to write bunch of functions, most of which should be automatically generated. What's the next function we need to write?
We now need to do increment or compare, one of the two.
Well, again, there are two kinds of increments. Sadly enough, we have plus plus and we have plus plus. We have plus plus here and plus plus there. Pre-increment and post-increment. All right? And again, many of you already heard, let me repeat, I strongly object to post-increment, in spite of the fact that I use it all over the place, causes bugs. I strongly object to plus plus returning anything at all. And if it should just move, and then you use it if you like. But my objections, I'm not designing a programming language. I live inside the language designed by Dennis Ritchie. His infinite wisdom, he provides us with two versions of plus plus. We have to make it so that they work for iterators exactly the same way as they work for pointers. That is, we live in this language environment, we have to totally imitate it. In some sense, when you enter a language, you have to put aside all of the things, or it could be done differently. No, it cannot. You live, it's like, of course, inflected languages, we have my friend Boris there, he says that, inflected languages with conjugations and declensions are so much more beautiful than poor languages like English. But we have to overcome the limitations. Shakespeare did, after all. So, we have to stick to to the language which we use. In this case, it's C. I mean, it's C++, but it's C++ is C, fundamentally. Extended, improved, generalized, but it's still C. How do we do it?
So we need to we need our operator plus plus with no parameters and operator plus plus with an int.
Okay, so there is let us first write down pre-increment. Pre-increment is fundamentally more basic than post-increment, as we shall see, because if you have pre-increment, you could implement post-increment. So let us first write pre-increment. So what does it return?
It returns a reference to ourselves.
It returns a reference to ourselves, not a reference type, not this. It returns a reference to the iterator. Why? Why does it return a reference? What's the intent? Okay. Yes, for example. For example, you could say plus, 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 plus. It works in C. Or you could say, what else could you say? No, but you could also say star plus plus. Right? This is a typical C idiom. We have to copy it. We have to return a reference to itself. So iterator reference. Is it const or not? This is not const. It actually modifies it, moves it along. Operator plus plus.
So now we need to call next. Is that right?
You tell us.
We want pool next.
And what do we do to do with pool next?
Oh, we're going to...
What do you want to do with it? Yes. So the code will say
node equals pool arrow next.
Yes. We need to get next, and that's our current position. Make it current. Yes.
And then we can return ourselves, return this.
Star this. This is this idiomatic thing. You always do that. All right? So now, how do we do operator post-increment? First of all, what does it return? Why copy and why not the original?
Because what we're going to do is we're going to make a copy of our initial value, then we're going to increment, then we're going to return that copy.
Because we're incrementing after we're returning. But after we return, we cannot increment. It's this undoable thing. I mean, first thing we want to do is, return, and then we want to increment. It's too late. So we have to copy. That's the only way known to humanity of sort of doing that. Okay?
So we'll return iterator.
Yes?
Operator plus plus int.
Yes, amazing thing. And I'm not going to explain to you why. Bjarne explained it to me multiple times. Next time when he comes, you know that he's coming, right? All of you accepted the invitation, I hope. And he's also going to teach this class. He will be talking about concepts, but you could ask him why it's int. Could be double. So you realize that it's just a syntactic way of saying, I mean, nobody passes anything to this thing. So this means that it's post-increment. This is pre, this is post. And this is always the same code, no matter what your class is. You write the same thing. What is the first thing you do?
We want to increment it. Well, we need to make a copy.
And we call it?
Result.
No, I'll call it temp. Because it is a temporary value. And it's...
That's a copy of star this.
Yes?
And Now we can increment ourselves, and we want to do that with pre. So we'll say plus plus star this,
Plus plus star this, just works.
and now we can return our copy.
Okay, so this is always the case. It should be automatically generated. These people should stop writing it, but it's, you know, it's in the hands of people like John, who might convince the power that be, you know, to do that, right? Because it is really tedious. Observe another thing. It would be criminal to make this operator to do something else. The semantics must be this. In spite of the discussions in the standard committee that somebody has a class where plus plus does this and plus plus does multiplication, it's a bad idea. They have to be these semantics. The semantics must be fixed. And standard should say that. Just this is, I'm trying to influence my people on the standard committee, or close to the standard committee. Yes. No, I mean, if you don't define it, the correct thing is that it should be automatically generated. And if you have a faster but conforming code, you could replace it. But it has to have these semantics. I mean, there could not be any novelties. Okay. Now, what we need is equality. And that is tricky. Equality is tricky. It's not tricky, but it requires thinking. Let us write. First of all, let's just write it. It's always equality looks the same. What does it return? It has to return bool. What else could it return? It returns bool.
Equal.
Even there you make a mistake, of course. We talk about it and talk for years. Is it a member function?
Oh, we wouldn't want it to be.
We wouldn't want it because it's a symmetric operation. It should do whatever it does on both. So we need to say friendable. See, these are little things, but we have to sort of assure that all of us always do the same thing. Okay. Operator, and it's typical, it's customary. Here, of course, passing iterators by value is sort of all right. But in general, inequality, sort of, you don't want to do copy. Why? It might be expensive, might fail, but more importantly, the very metaphysical level, what is a copy? Copy is something which is equal to the original. Equality is a more primitive thing, so let us try to define it without referring to a copy. This is metaphysics for those of you who like it, but it's an important metaphysics. Equality is more important than copy. I mean, it's not important in some, you know. And of course, I could make a long speech about language designers who use two equal signs to designate equality instead of one equal sign, but I'm not going to because it's too late. But I really think it was a very bad idea because there's a mathematical notation used for centuries, blah, blah, blah. You heard the story. Const
iterator ref. And we need
to name it somehow.
well, we can call this the LHS. And
I would call it X. When you have, in general, for everywhere, I think that when you define equality of two things, it's either X or Y or A and B. You could, of course, say D and W, and it will work. But there is something fundamentally wrong about it. X and Y is an acceptable choice, A and B acceptable choice. You know, sorry for that, but these are just, they have no meaning except they're X and Y.
okay, and we need another.
Yes, and we need to call it Y. We could call it A, but it will confuse the reader. Yes?
Some people use left-hand side and right-hand side.
For equality?
Yeah,
That's what I said,
And then
LHS.
some people get mixed up.
For a symmetric operator, no, guys, use, again, what I claim is that whatever did you take algebra class in the 5th grade?
I don't use left-hand side.
No, but when you took it, they used X and Y, and it's good. You know, actually, I claim 5th grade algebra is a very good thing to remember. You know, mathematics is an old discipline. We should stick to it, X and Y, at least as long as you are in my class. Of course, then you will go and write things. I've seen the things you write. So, but here it's X and Y. And here comes the tricky part. Here comes the tricky part. Why is it tricky? Okay, suggest an implementation.
Well, we could return that the pointers are equal and the indexes are equal.
And I know that John is not going to do it, and I'm not going to do it. Why are we not going to do it? Takes too long. See? We didn't talk during, you heard us talking. We didn't discuss it. We're not going to do it. Because we say it takes too long. And there's no person, however mad, who's going to take 2 allocators, 2 pools, and start comparing iterators from lists and tuples. And if he does, he deserves what he gets. Right? There's, in some sense, this is a discussion which I had with the standard committee and with all my life. They say, but couldn't we guarantee safety when we compare 2 list iterators? Meaning that it's the same list. No, guys, it cannot be done. Because they say, no, but couldn't you keep a tag to the list header? No, I shouldn't. Moreover, nodes move from list to list. There's this wonderful thing, replugged, which allows me to move. That's why I want to have lists. Right? So you have to ignore it. You have literally, so the way I would write it is I would still put an assert. And since I don't know how assert is implemented and what will happen in the particular build system, I'll comment it out. That is, I want you to know what I intend. And I do want x dot p to be equal to y dot p. Otherwise, who knows what happens? It's but I, believe it or not, after that, there is a stronger statement. I basically want all of my operations belong not just to the same pool, but to the same list. Remember, let's assume we're trying to find something, or whatever algorithm would do it. It's not enough that they come from the same pool. It's just not enough. They have to come from the same list, which is, again, I cannot check. And in some sense, again, I'm going to get many angry letters after saying what I'm going to say. Safe programming is bogus programming. That is, programming has to be done right, but no syntactic rule saying, oh, let us always check that pointers point to the same array at runtime. Let's build the system. No, you have to write correct code. You want to prove it correct? Wonderful. But you cannot make it correct by bizarre syntactic limitations. It just cannot be done. In some sense, Turing machine is fundamentally unsafe. It could loop forever. As long as you give me while statement, I could write an unsafe program. So every time, it's like people go and fix iterators. Like they say, all iterators will contain a pointer to the header of the data structure. And every time we compare them, we'll check it's the same header. They make it much slower, and there's still millions of bugs of different nature. I mean, this is only one sort of bug. Right? So, whatever, the end of a diatribe. we go back. Yes.
The only people I know that do so for bug builds, which I think
No, for debug builds, it's mildly useful. The only truly useful thing for is to decompose your program in clear subroutines and clear units which you understand. That's the only thing I know which works.
right, but the debug iterators in this case are useful for like silly mistakes.
For very silly mistakes by very silly programmers. That's the problem. They shouldn't be using it. They shouldn't be programming. They should be they should be programming in Python. So no, but seriously, guys, the reason you should program in C++ is that you want to have access to the machine. You want to have these unsafe things called pointers. If you want a language which does not allow you to touch the machine, which hides the machine, which makes it safe, use it. It has its advantages. I'm not putting Python down, by the way. For writing scripts, it's a perfectly wonderful language. But don't write your operating system in Python. Don't write your search engine in Python, not the core at least. Right? So the languages have, even BASIC is a wonderful language for what it is. COBOL for sure was a wonderful language. But again, I wouldn't want to use COBOL for writing an operating system. So, okay, and now?
Now we just need to check the note.
So this is the key thing, because that we must check. Right? We have to understand that even the fact that every iterator has to carry its pool is a limitation. It might affect performance. Fortunately, it usually doesn't. The compiler sort of quickly realizes that they're identical. So, and then we write another thing we shouldn't be writing.
Oh, you mean another, yes, we shouldn't have to write.
But we have to. And again, the semantics must be fixed. It's non-negotiable. The semantic of not equal has to be not equal. There's no other. Okay, so.
So again, it's a friend. Again, it returns bool. Operator.
The same, yeah.
Same parameters. We could pretty much have copied that and just tweaked.
And we know the implement. No, we will not tweak. How should we write it?
You would want to say return not
X equal Y. Because that's the fundamental algebraic definition, that this means this always, not just for our iterator type. Now, we come to somewhat delicate point, which here I have to explain something which is sort of difficult. So we all know that forward iterators do not have less than defined on them. Why? Is it a good design?
Can't apply to the first case.
But wouldn't it be sometimes useful to have it? When? It's too expensive to do. If you want to do it right, it's too expensive. And not even guaranteed to terminate. If I give you 2 pointers to linked list, to finding, but here you are thinking what you don't necessarily need to think. You think that if I am less, I am before. This is only one interpretation. The reason I did not provide less was complicated. Let me now explain. Because I clearly knew that I cannot efficiently, effectively implement before on forward iterators. But I was very tempted to include less than, which will do a very simple thing. It will just, what is the most common case of forward iterator? Pointer to a linked list. And what I was terribly tempted is just compare pointers and return whatever the comparison returns. Why I was tempted? Okay?
Because then you can store the iterators in map or some other data structure.
Or I could sort them. Right? So this is this amazing thing that I don't need the semantics of before after to be able to use them for fast binary search, whether in a map, whether in a sorted array. And you say, why do you want it? Well, let us assume I want to find out if I already have this iterator. Inclusion in a set. The only effective way, let's ignore hashing for a while, is through comparison. And I was torn. I was really torn because I knew I cannot include less than for the following reason. Because already most people would attempt to write code in STL the old way which they learned to write. They'll write while I is less than j. Remember, they even taught you that this is a better code than STL style not equal. But it doesn't work for linked lists. It doesn't work for maps. It doesn't work for any linked structure. And if I provide it for linked lists, people will merely write it, and it will compile. And it will work, meaning I don't know what. That is, it will iterate through some part of the list based on totally mad things. So that was not an option. Right? But I still want to emphasize the fact that total ordering is a universally useful thing. And one of the problems, which sort of, that it needs to be provided, fortunately, if you think about it, we work on this computer where it is fully defined on every byte. It's fully defined on every word as an integer. It's even defined, let me not go into details, somewhat on double. We talked about some issues with double, right? Because double is, but let's ignore bad values of double. It works for double. So it's naturally extendable less than to things like struct as equality. It was an oversight on part of C and still C++. Again, for over now close to 30 years, I've been advocating that equality should be generated the same way as constructors. Right? If I don't provide an equality, do element-wise, it's a natural thing. You could end an equality like that, and you could do less than using what? Lexicographical ordering. It's a natural thing. What is, and that's how it's done for things like pair, say. But it's not done. And therefore, you have to sort of think about it. But the issue remains. It's not, here I'm just showing you the thing which you might have to deal in a situation. So, if you have the situation, how will you solve it? If you want to have a set of these iterators. Yes? What kind of custom comparator? Yes, the one which compares the addresses of the elements to which iterator points. It's nothing to do with before or after, but it establishes a total ordering, which is the only thing. And people forget that total ordering to make a set is an arbitrary total ordering. It doesn't have to be topologically induced. by the traversal. Very good. Yes?
Total orderings on pointers
Is not defined. I know that.
maps is guaranteed to give you total ordering, but it's not specified.
Actually, less than for pointers is not defined. Less than is defined only, this is in the standard, which I think is a horrible statement. It says that less than is defined only if these are pointers to the same array.
Right, but the less
We're not going there yet. Just give me a second. This is a very important thing to remember. That, by the way, it works on every computer and every compiler will do the right thing. But the language tells you you cannot do that. Right? There is a language purists who make big money by telling you that, who say that there is a thing called less angle bracket, the name of your type, angle bracket, which allows you to compare two void stars wherever they are. This is again one of these things, and it's bizarre and complicated, but sadly enough, working programmers need to know that. But effectively, we do not want to define that. Okay? We are almost at the end, and we cannot do what I wanted to do, but I want to do one more thing. Well, we need to provide constructors. Constructors.
Okay.
Do we need to provide any destructor?
I don't think we have any resources that need to be free.
No. Of course, it will synthesize a destructor, which will do nothing at all, but that's exactly as we want.
And also we'll synthesize a copy constructor for us, which
Yes.
so it would be good that it does that.
And assignment.
Yes.
So all of these things will be provided for us, which is good, because without these things, we couldn't do much. What constructor do we need?
We need to be able to give it the pool and node that we want to.
Yes.
So it would take a pool and a node. Yeah, a list pool pointer, list pool star.
I wouldn't take a star.
Oh, because you want to require that there always be one. So if we take it by reference,
Yes.
all right, and then
But you need to call it something.
we'll call it pool. And then we need the node, again, the list pool, list type. And we can call that node. And then we can initialize our pool member with the pool, address of the pool, yes, and our node with the node.
I think we need one more, very good, but I think we need one more constructor. It will come handy.
A default constructor,
Default constructor, no.
okay.
Default constructor will be hard to make. It would be wonderful, but it will be hard to make. I should have tried you writing it. Then you will found the problem. We're at the end of the class. I'm not doing it properly.
Right.
You see, it's very good to have a special case for null. For the null, the node which does not exist, nil. Because of course you could explicitly use nil and use this constructor. But you could also say, if you don't give me a node, then I'll get nil.
Then we could make it a default value on this and just use it.
Yes.
Or we could make a separate destructor.
I would make a separate constructor.
Then we would still want to pass the pool in. Because that's the tricky part about having the default constructor anyway, so you really need the pool.
You really need the pool. That was the problem. Because you really need the pool to find its nil value. Because nil value, if you remember, depends on the pool.
Okay.
And of course, I forget.
Initialize our member, our pool member with the pool. And then do we have a way of calling the pool to get its nil?
Yes? But that's here you're going to encounter a little problem. Even if compiler is not confused, you're going to be confused. Which pool are you using? Outer one or inner one?
It wouldn't matter, they're the same.
Well, yes, it would, because one of them is a pointer, another one is a reference. You write them differently.
So we can say this pool.
Or you call this guy P, which will eliminate the problem. Which then I would suggest that you call this guy P as well, for symmetry. And how do you get its nil? Ryan, show us how to get a nil. Is it empty? Yeah, I think it's empty. It's pool.empty. Pool. No, this is P dot. This is why they're not. P and pool are of different types. Okay? So now we could try to compile all of that.
I think that we should include a default constructor, even if it has bad values, because oh, it can't write something like this.
No, you should put a default constructor, yes. Yes. Put a default constructor, yes. Everything must have a default constructor, and the only requirement on the value generated by default constructor is that it's destructible. It couldn't be used for anything. So
Then we probably want to add some asserts to the operations that dereference the pool.
why?
In case somebody tries to use the default.
You should not rely in general, sort of, unless the semantics is specified and say, or just write comments say, creates a partially formed value. If you want to know what partially formed value, read Elements of Programming, page whatever. You should read it anyways, but it's not the first time I'm saying it. Yes, you read it?
I've read part of it, but the standard
First 3 pages.
singular iterator for this.
What?
Standard uses the term singular iterator.
I'm happy to know that. And I use the partially formed value is a more general term, saying the only thing you could do with this is to destroy it or assign to it. Okay? And it applies not just to iterators, but to anything. Tell your friends on the standard committee to read this book called Exactly. See, you could read my mind. So they might learn something. It's unlikely. But now I would like to try to compile. Because you see, we use the iterator in the new code. And it used to work before we started all of that. Start running it. Yeah, it's correct. You might not know, but it is correct. The two very different algorithms return the same result, so it's correct. It's pretty amazing. John? Guys, it is impressive. He led the development of yes, right on time. Do we have 1 more minute? We have 1 more minute. So let me tell you where we need to go so that you could try some of the people want to be ahead of the class, like Hernan is always ahead of the class. So what our task is, first of all, extend this iterator to a thing called linked iterator. Iterator which would allow us to do replugd. Right? We want to provide an operation set successor. Because in linked lists, you could change the successor. Very useful. First step. Then, I'm just telling you our program, so you could attempt. You could also do, I forgot to tell you, show them what Hernan did. You are going to be able to read his code. He redid all of this stuff in Common Lisp. Those of you who know Common Lisp should read it. It's very instructive. So if you go to this directory, Hernan's code is there. Okay? There are certain people who promise to implement it in Java and Python. I'm waiting. In Python. Great. Okay, we will put it in. Wonderful. Of course, Dan, he has things, but it doesn't matter. It's Java. Why don't you do it? You're the local Java guy. Nothing is capable enough, but as even C++ is not capable enough. We have to fake things like type functions, stuff like that. But was it instructive to do it in Lisp? Was it instructive to do it in Python? You understand the algorithm much better, and you understand Python or Java or Common Lisp because you see their limitations, what works, what doesn't work. It's a good exercise. It's a challenge. Paul tried to do it in Haskell and found it wanting. Apparently doing all these imperative style functional forms in Haskell. But if somebody can, it would, rethinking algorithms in different languages is always instructive. It's a good thing. Right? So, and especially if you consider yourself an expert in, say, Java. Try it. It's not much code we have. I mean, look, it's small code. So try to see the best you could do, whatever it might be. Okay, so again, we will extend the iterators to do replugd. Then we will implement merge, like that, linked list. And then we will use our wonderful counter machine to do merge sort without using any recursion, because there are silly people who say, well, first we will run to the middle of the list split. No, this is awful. We're not going to do that. All right? So that's, and I think that even if you do it in Lisp, it will make the next lecture so much more convincing. Thank you, guys. Hopefully, at least a few of you will remain.